Yeah, fine. All right. Okay, I just started the recording. So formally, once again, good evening, Rajeshwari, Sashmin and Nandini. And good evening, class. Good evening, all of you. Yeah, so this is the first question for today's class. Take down the question and start working. What is the formula to find the volume of a hemisphere? Sorry? Is he right? 2 by 3 pi r cubed? 2 by 3 pi r cubed. Is that right? Nobody confidently, yes. Yes, online children, 2 by 3 pi r cubed is the formula to find the volume of a hemisphere. Okay, no wasting time. Yes, that is the formula. Why? Not confident. 2 by 3 pi r cubed. The volume is given to be, am I audible? Online children, am I audible?
Yes, ma'am.
Is my presentation visible? I've shared my screen.
Yes, ma'am.
All right. So convert this to a mixed improper fraction. So 2 by 3 pi r cubed is equal to whatever. And find the value of r. What's the improper fraction? 4851? 4851 by 2. All right. Yes, let me see who can give me the value of r first. The value of r. Quick. This is actually of 9th standard, not 10th. What is r squared? 2 by 3 pi r cubed. See the screen. Bring that Yes, Nandini, Rajeshwari, Sashwin, what's the value of R? I must say the class is slow. Yes, you have the value of R? Working. Okay, that's very slow. So I'll work this. So those who want can look at the board. Online children, look at your screen. So 2 by 3 into 22 by 7 into R cubed is equal to 4851 by 2. So R cubed is equal to transpose 4851 divided by 2. 2 by 3 becomes 3 by 2 on the other side. And 22 by 7 becomes 7 by 22. Now, whenever we have 22 in the denominator, mostly some number in the numerator should be divisible by 11 or maybe 22 itself, because 11 twos are 22. So there must be some number in the numerator. It's just a guess. Okay, there should be some number in the numerator which is divisible by 11. So let's try this. Let's try this. 11 fours are 44. 4 remains. 11 fours are 44. 1 remains. And 11 ones are 11. So see there. Then this is two times. Okay. Now see here. R cubed is equal to, we have 3 2's in the denominator. So don't multiply. R cubed, right? Don't multiply. See here, R cubed is equal to, you should not multiply. All of you have multiplied. You should not multiply. Okay, divided by 2 into 2 into 2. Now see, I get the clue from this itself. 3 7s are 21. So mostly 21 into 21 is 441. Because I must have 3 equal primes in the numerator and 3 equal primes in the denominator. R cubed, right? So we have 3 2's. Fine, so 1 2 will come out. And now the numerator also should be a perfect cube. Now see here, what is 441? Leave 3 and 7. I'm not multiplying. What is 441? 441 is 3, 3 ones are, 3 fours are 12, 2, 3 sevens are. Again by 3, 3 fours are, 3 nines are, 7 sevens are, 7 ones are. So R cubed is equal to, I'll just continue here. R cubed is equal to, what is 441? You should not multiply 441 into 3 into 7 and get a bigger number. You should not multiply. You must find the prime factors of the numerator. 3 and 7 are already primes. Leave that. 441. Don't multiply the numerator. Meaning don't multiply the numbers in the numerator. Break down into their prime factors. So now what do you get? 441 is 3 into 3 into, you can write this 3 also along with that. See here like this. There's already one 3 there, no? Into 7 into 7 into 7. Am I clear? There's already one 3 and 7 here. There's one 3 and 7. There are 2 3's here. So totally 3 3's. And there are 2 7 here. And there's 1 7 here. So 3 7's and all. I hope I'm not confusing you. Divided by 2 into 2 into 2. So now what is R then? R is equal to, from 3 3's, 1 3 out. From 3 7's, 1 7 out. R cubed is equal to this. So R is equal to, oh, I can't write here, so I'll write it like this, is equal to 21 by 2. Wasn't that easy? Yeah. But why so long? Yes, Trace. You should never, whenever you're finding, you have an equation like R square is equal to, or R cubed is equal to, don't multiply. Don't multiply. Find the prime factors. If it is R square from 2 equal primes, you'll bring 1 out. If it's R cubed from 3 equal primes, 1 will come out. So see, it's just this. And now we'll have to find the CSA. So see, if you know it now, since if you know it, you can write this straight away. See, now say you know 21 into 21 is 441 children. Look at the screen again. Now supposing you know 21 into 21 is 441. So in the next step, you can directly write 441 is 21 into 21 and the 7 3's are 21. That's fine. We are not in 7th or 8th standard to write only prime factors. You are in 10th. It's okay. You don't have to write prime factors. Correct? You can just write it like this. See, 7 3's are 21 and 441 is 21 into 21. So we have 3 21's and 3 2's. So cube root, and I hope you understand. Yeah, complete this. Where were you struck, Nandini, Rajeshwari and Sashmin?
Ma'am, I actually multiplied all the numbers, ma'am.
What about the others? Rajeshwari,
I
Sashmin?
to multiply all the numbers now.
Okay, okay. So that way we are complicating it. Not that you cannot find. You have to find the prime factorization. You have to find the prime factors of what was that? 9261. Yeah. Done writing, children? Shall we go to the next one? So I have written R is equal to 10.5, but then I've taken 21/2. So you can use anything. You can use 10.5 or 21/2. That's your choice. Done? Okay, this is the next question. One second. Yeah, this is the next question.
Ma'am,
Yeah.
ma'am, in the last question, CSA of the hemisphere is 693 centimeters square, right, ma'am?
Thank you. Yeah, 693 centimeters square. Typing mistake. 693 centimeters square. Perfect. Yeah. Yeah, this is the next question. 150 spherical marbles, each of diameter 1.4 centimeter, are dropped in a cylindrical vessel of diameter 7 centimeter containing some water, which are completely immersed in water. That is, the marbles are completely immersed in water. Find the rise in the level of the water in the vessel. Now, let's just recall some certain things from 9th standard. All of you look at the board. Online children, look at your screen. Now, consider a cylindrical vessel. Okay, a cylindrical vessel. I'm just drawing it like this. It's a cylindrical vessel. Okay, the same cylindrical vessel here. The same cylindrical vessel here. All right, now this is filled with water. Filled with water. Say the height of the water is 7 centimeters. And the height of the vessel, say, is 21 centimeters. Okay, let me reduce the height of the water. I'll just reduce the height of the water. Don't start working this. All right, so you can see cylindrical container, the height of the container is 21 centimeter and the height of the water in the container is 7 centimeter. And let's say the radius is also 7. And now the marbles are dropped and please listen. Okay, so some number of marbles, okay. Marbles are dropped here. Now this is the initial height of the water, 7 centimeter. And now say it's now this one is what we'll have to find. Okay. All right. So there are many marbles. We'll just assume 150 marbles here. Okay. 150 marbles here. All right. Now, first question, Hitesh. What is the, I don't want the final answer. Just tell me like 22/7 into this, into this, into this. I just want that. I don't want the final answer. What is the volume? It's a cylindrical container. What is the volume of the water in the cylindrical container? Volume of water before the marbles were dropped. in figure 1. In figure 1, this is figure 1, this is figure 2. In figure 1, what is the volume of the water in the cylindrical container? Quick. Yes, you. No, that's long time. Write and read then. All of you write, I think, just write it fast in your book, all of you. Don't work somewhere behind, just write the formula, substitute the values and have it ready. Don't write the question, children, don't draw the figure. I just write this answer. What is the volume of the water in the vessel? Write that formula, substitute the values and have it. Online children, anybody ready with my ready with the answer to my question? Yeah, Deepika, read now. What is the volume of water? Louder. 22 by 7 into. I want that. Sneha. Perfect. The radius of the cylinder is 7. The height of the water is 7. So the volume of the water in the vessel is, see, the radius will be the same. The radius for the water takes the shape of the container. Water takes the shape of the container. So water in the container is also cylindrical in shape. The water in the container is also cylindrical in shape. So what will be the radius of the water? 7 centimeters. What is the height of the water? 7 centimeters. So and what is the shape of the water in the vessel? Cylindrical. How do you find the volume of water? Pi r square h. 22 by 7 into 7 into 7 into height 7 is the volume of the water. What is the capacity of the container? Shreya Shri, what's the capacity of the container? What's the radius of the container? What's the height of the container? Then now put the values in the formula and tell me what is the capacity of the container? What's the formula? Very good. Yeah. 22 by 7 pi r square h again. The capacity of the vessel is 22 pi r square h. 22 by 7 into 7 into 7 r square into h. 21. When you take the height as 21, you get the capacity of the vessel. The capacity of the vessel, that is the volume of any liquid it can hold. It can actually hold. When you take the height of the cylinder, when you take the height of the water, you'll get the volume of the water in the vessel. Depending on what height you're taking, the corresponding volume you will be finding. If you take the height of the water, you're finding the volume of the water. If you take the height of the vessel, then you're finding the capacity of the vessel. Now that these sorry, the radius is 7 in my figure, not in the question given. In my figure, the radius is 7. I've marked only from here. The radius is 7. Now in figure 2, now this increase in the level of water is because of the marbles. This increase. It was already till here. Now this increase in height is because of the marbles. So the volume of all the marbles is equal to this volume of water. See, the water level of the water was only here. Now, why did it increase? That's because the marbles have taken space inside the container, due to which the height of the water in the vessel has risen. Yes or no? So why this increase in the level of the water is because of the marbles, which means the volume of this water. How will you find the volume of this water? Take that height. If you keep changing the height, you will get the volume of that portion. You just have to manipulate the height. So the volume of this portion of water will be pi r square h. Pi r square is the same thing. because there also the water is cuboid and cylindrical. That portion also water is cylindrical. So what will be the volume? Pi r square h. What is R7? But what is h? We don't know. We don't know h there. That is what you'll have to find. Find the rise in the level of the water in the vessel. That's what we have to find. So that increase in the volume of water. So pi, this volume of water, okay, 22 by 7 into 7 into 7 into h is equal to volume of all the marbles. All the marbles, not one marble, all the marbles. One marble is 4 by 3 pi r cubed because it's a sphere. Volume of one marble is 4 by 3 pi r cubed. Volume of all the marbles will be 150 into 4 by 3 pi r cubed. This is the equation wherein you know all the values except h. So work this and find the value of h. And that will be the height. That will be the height of this portion or the increase. That's the increase. Work, children. Online children, was it clear? Please work, and if you have any further questions, you can ask me. Please acknowledge Sashmin, Nandini, and Rajeshwari.
Okay, ma'am.
Yeah, all right. First, you can just have a look at the answer. First, have a look at the answer. You're just writing. First, have a look at the answer. Then you can just blindly copy also. First, read and see what is happening. Once you understand, then you can just start writing. See, I've differentiated the R's. Now, you know that the radius of the, see, you can use R1, R2 also. You can use R1, R2. I've used a small r for the marble and a capital R for the cylinder because of the value, but nothing like that. You can just say R1 and R2 also. Okay. I have used a small r for the sphere and capital R for the cylinder, and height is h because we don't have, meaning we don't have to use h for a sphere. So I've not used H1, H2 or anything. It's just H here. H is what we'll have to find. And this is what you should write in words first. Increase in the volume of the water in the cylinder is equal to volume of 150 marbles. This is what you should write in words first. Write this in words first. And then what is the formula for this one? Pi r square h. And what's the formula for this one? 150 into 4 by 3 pi r cube. Once you write this, you should first write it in words. Whatever you've understood, write it in words first. Write it in words and then use the formula and convert it to a mathematical equation like this. Substitute the values and find the value of h. So this portion alone, that increase, this one is 5.6. So the increase in height is 5.6. Yeah. If you want to take 0.7 or 7 by 10, please take, calculate it. And then this one also 7 by 2. If you want to take 7 by 2, please take 7 by 2. Pi? Yeah, pi gets cancelled on both the sides. I've cancelled it. Meaning I can't show it here, but it's cancelled. You can do it here itself. Pi and pi gets cancelled on both the sides. Yes. Sure, sure. Yes. Oh, right there. Yeah. Oh, yeah. Yeah. Turn on the lights. It is outside there. Both of them. Yeah. Done, children. Any questions? So I'll tell you how I have worked this. So I have cancelled, meaning I've shifted the decimal points here. This one moves here, this one moves here. So it will become 7 and 35. 7 ones are 7 fives are. This one it will move here. This one you can shift one place in the numerator and one place in the denominator. So I'm shifting one in the denominator. So 7 ones are 7 fives are. Okay, then 5 ones are 5, or I can say 5 fives are 25, 2s are 50. Then 2 into 4, 8. 8 into 7 is 56. There's a decimal point, so 5.6. So when 150 marbles are dropped in the cylinder, the level of the water increases by 5.6 centimeters. Clear, Deepika? Can we go to the next one, children? Yeah. A cylindrical tank, you completed the earlier one? Okay. A cylindrical tank full of water is emptied by a pipe at the rate of 225 liters per minute. So you understand. So when the emptying pipe works at the rate of 225 liters per minute, so much of water is emptied. How much time will it take to empty half the tank? If the diameter of the base is 3 meters and its height is 3.5 meters, how much time will it take to empty half the tank? And now you don't know the shape of the tank, right? But you can see the values given for the tank. The diameter is 3 and the height is 3.5. So what should it be? Now don't say conical. If it's conical, and it's given no in the beginning also, a cylindrical tank full of water. You can see it here. A cylindrical tank full of water. So it's a cylindrical tank. The diameter and height is given. So for a cylinder, what do you need? Radius and height. That's given to you. And the emptying pipe, I have a feeling we've already worked this. No? Sure. Similar, we've worked this. Oh, okay. Okay. So the emptying pipe empties. It's like this, supposing there are 100 chapatis. Okay, just imagine there's a giant and the giant can eat, the 100 is too less for the giant. So some 1,000 chapatis. Okay, there are 1,000 chapatis and say this giant can eat at the rate of 10 chapatis a minute. This giant can eat 10 chapatis a minute. So how long will it take to eat half the number of chapatis? How long? So what is half the number of chapatis? 500. And what's the speed? 10 chapatis per minute. So then 500 chapatis, how many minutes? 100 chapatis, how many minutes? 10 minutes. Do like that. 10 chapatis per minute. 1 minute, 10 chapatis. So 10 minutes, 100 chapatis. So 500 chapatis, 50 minutes. 50 minutes. So there are 1,000 chapatis. But we are talking about how long the giant will take to finish eating half the number of chapatis. So 500 chapatis. at the rate of 10 chapatis per minute. So like that, there's a tank. It's full of water, but you don't want to empty all the water. You want to empty only half the volume of water. So what should you find? First, find the volume of the tank. Then find half the volume of the tank. Or you can directly find half the volume of the tank, half pi r square h. Half into pi r square h will give you half the volume of the tank. Now that volume is in meter cube. That volume is in meter cube. Convert that to liters. You have what's the conversion? Who can say? Sashmin, Nandini, Rajeshwari, what is the relationship between Rajeshwari is not active today. Are you there, Rajeshwari?
Ma'am, 1 meter cube is equal to 1000 liters, ma'am.
1 meter cube is equal to
Ma'am,
1000
actually,
liters.
we have worked this question before, ma'am.
In the class?
Yes, ma'am, in the online class.
That's what I was telling you.
We have already worked this whole presentation, ma'am.
I asked you children, see, that's what that's what I asked when I started the class. I had a feeling when I saw the first question, I had a feeling that in spite of that, you were not able to answer my questions. All right, we'll finish this. We are revising that. Okay, Nandini, fine, thanks. I'll change the presentation. Now we have the volume of the tank in meter cube. Convert that to, so what is the conversion? Nandini just told us. 1000 liters is equal to 1 meter cubed. 1 meter cubed is equal to 1000 liters. What do we understand by that? 1 meter cubed is equal to 1000 liters. That means, imagine a cubical tank. The tank can be of any shape. The tank can be of any shape. We'll just take a cubical tank so that it's easy to visualize. Imagine a cubical tank, 1 meter long, 1 meter broad, 1 meter high. Imagine cubical, no? So obviously the length, breadth, and height are all the same. Okay, a cubical tank, 1 meter long, 1 meter meaning 100 centimeter, 1 meter long, 1 meter broad, and 1 meter high. Now, what is the volume of this cubical tank? 1 meter cube. 1 meter by 1 meter by 1 meter is 1 meter into 1 meter into 1 meter, which is 1 meter cube. The volume of this cubical tank is 1 meter cube. Now, this tank can hold 1000 liters of water, is the meaning of this conversion. Approximately. Now, if it holds only 999 liters of water, you cannot question the mathematicians that it is their equation is wrong. So it can approximately hold 1000 liters of water. Do we understand that? Now it need not be a cubical tank. Trace, it need not be a cubical tank. It can be even a cylindrical tank or a cuboidal tank whose volume is 1 meter cube. So if the volume of a container is 1 meter cubed, then it can hold 1000 liters of water. Understand? That's what is a conversion. Now you would have found half the volume of the tank, correct? Convert that to liters. Then 225 liters is emptied in 1 minute. Then this 10,000 liters will be emptied in how many minutes? Right on. Before you actually write now, let me tell you what the way I have worked it. See here, this is how I convert. This is how I convert. After finding Shreyas, you're tired today? You're not well? You're fine? Okay. Now see here, half the volume of the tank is this one. Now I have to convert this meter cube to liters, right? So see how I convert. 1 meter cubed is 1000 liters. Then 12.375 meter cubed is X liters. Cross multiply, that's all. Because often, we have a doubt if we should multiply by 1000 or divide by 1000. And in the exam, you're like normally a little tensed. So then we may go wrong. So use this, you will never go wrong. 1 meter cubed. 1 meter cubed is 1000 liters. Then 12.375 meter cubed is how many liters? X liters. Now cross multiply. So when you cross multiply, you get X into 1. X is equal to so many liters. Now the next thing is, see here again. Next, 225 liters is emptied in 1 minute. Then 12,375 liters is emptied in 1 minutes. Again, cross multiply, you will get the time. That's all. This is how you should work it. See, you should have this is called a proportion. In the proportion, you must have the same units in the numerator, same units in the denominator. Meter cube in the numerator, liter in the denominator, or liter in the numerator, meter cube in the denominator. Same thing here. Sorry. Liter in the numerator, minute in the denominator, or the other way around. Work. Finish, children?
Yes, ma'am.
Okay,
Yes, ma'am.
all right. Is the working understood? Is it clear? Done, Shreya? Finished? Priyanka? Yeah, it's time. What about this, Nandini? Please check your book. I asked you people when I started. This is over. The same presentation. Okay, this I've definitely not done. Let's do this now. Okay, fine. Now you just Nandini, take a picture of all these questions and check in your book if you have already done this. Take a screenshot of this one.
Okay, ma'am.
This.
Done, ma'am.
Yeah, this one.
Done, ma'am.
Yeah, now we'll do this one. I'm sure we have not done this. Now find the volume and TSA of the solid generated when a right triangle with legs 24 centimeters and 10 centimeters is made to revolve about its hypotenuse. So in standard 9, we have seen the solid generated when a right triangle is made to rotate about one of its two legs. Okay, this is a right triangle. Right triangle, let's call it ABC. So the right triangle is right angle at B. So these are the legs. This is one leg, this is the other leg, and this is the hypotenuse. This is the hypotenuse. Correct? Now, what we have studied in standard 9 is when a right triangle is revolved about one of its legs. About one of its legs. Can you just give me open? You have a paper with you? Don't pull a paper. Anybody has a loose paper? Oh, I think I have it. We just pull out a paper from your book. Can I have a paper from one of you? Looks like nice sauce this time. Okay, so this one is a this is a right triangle. Yeah. So this one is a right triangle. Right triangle. Okay, so this is one leg, this is the other leg, and this is the hypotenuse. This is the hypotenuse. This is the hypotenuse. This is one leg. This is the right angle. This is the vertex that contains a right angle. So this is one leg. This is the other leg. Now, when you turn the right triangle about one of its legs, see when you turn it like this, when you turn it like this, when you turn it like this, then bring it back to the original position. I'll send a video on this. You can understand better, like clearly. I'll just tell you what I'll demonstrate my best now. I'll share a video. This is a right triangle. This is its leg. When you turn the triangle about one of its legs, when you turn it like this, okay, it traces here. This leg will trace a circle below. And the right triangle will trace the shape of a cone, a right circular cone. You cannot get a cone. The right triangle will be a right triangle only. It'll trace the shape of a cone. When it goes like this, it's a paper, so it's flying. So when you turn it like this and bring it back to the original position, it would have traced the shape of a cone. It will not become a cone. It's a triangle still. Okay, we are not magicians. Sorry, the triangle will not become a cone, but it will trace the shape of a cone. The other leg will, this is the radius. The other leg will trace a circle. This leg will trace a circle. This will be the radius of the circle, and this will be the height of the cone. This will be the height of the cone, and then this one will trace the CSE of the cone. Sorry, the curved surface area of the cone. So this is one leg. This is the other leg. This is the right angle. Or we are turning the right triangle about one of its legs. So this leg, when you turn it like this, and bring it back to the original position, the right triangle would have traced the shape of a cone, a right circular cone. This one being the height of the cone, this being the radius of the cone, and this one will trace the curved surface area of the cone. The same thing when you trace it, when you turn it about this leg. When you turn it about this leg, also same thing will happen. Same thing will happen. But when you turn it about its hypotenuse, this is the hypotenuse. This is the hypotenuse. See, this is the right triangle. This is the right triangle. I'm having it like this now. This is the hypotenuse. Here is the right angle. Here is the right angle. This is the hypotenuse. When you turn it about its hypotenuse like this, when you turn it and come back to the original position, see, you're going like this. You're going like this and coming back to the original position. Then the hypotenuse, when you turn it about its hypotenuse, a cone is generated on this side and on this side. So it traces a double cone. Now, the thing is, in this triangle which I have, these two sides look almost the same. So maybe you're not able to visualize that. I'll share a video wherein you can, or maybe see in this figure, you can understand. This figure, see here. See this? So there's a cone formed on this side. This is the hypotenuse. The right triangle is ABC. The right triangle is ABC. Right angle here at A. BC is the hypotenuse. BC is the hypotenuse. When you turn the right triangle above the hypotenuse, a double cone is formed. One on this side. Can you see that AB, A dash, that side is one small cone. And on the other side, AC, A dash, a bigger cone. So on either sides, so two cones are generated. They're stuck to one another. Their bases are stuck. Their bases are stuck. Their circular portions are stuck. Only the curved surface area of both the cones are visible. You cannot see the circles. The circular part of both the cones is not seen. They're stuck to one another. Can you see that figure here? When a right triangle is made to revolve, about its legs, the solid generated is a right circular cone. When a right triangle is made to revolve about is made to revolve about its hypotenuse, then the solid generated is a double cone. Two cones stuck to one another. Their circular portions are not visible. So if you have to find the total surface area of the double cone, it is the CSA of the small cone plus the CSA of the big cone. Because the circular portions are not visible. So you only can see the CSA, the curved surface area of one cone, and the CSA of the other cone. That will be the total surface area. Even if it is total surface area is whatever surface area you can see or feel. You should not use total surface area formula. Okay, so maybe the video which I shared will make it more clear. Now let's answer this. Listen to me very carefully. Very simple. Now, I'll read the question again. See, find the volume and TSA. Find the volume and TSA of the solid generated. So what is a solid generated? A double cone. A double cone. When a right triangle with legs 24 centimeter and 10 centimeter is made to revolve about its hypotenuse. All right. Okay. So a double cone is formed. There's one cone here. See, one cone here with this circle. And the other cone here, like this. This is the other cone. And the same circle, because they're stuck to one another. Now, the legs are 10 and 24. So you can see here, 10, 24. Legs are 10 and 24. So what's the hypotenuse? By Pythagoras theorem, the hypotenuse is 26 centimeters. Is that fine? BC is equal to, you understand this, hypotenuse is 26. The legs are 10 and 24. So AB is one leg. AC is the other leg because they only contain the right angle. They only contain the right angle. They are the legs. And opposite of the right angle is the hypotenuse, this one, which you find using Pythagoras theorem, 26 centimeters. Okay, now, what are the things you need about the two cones? What are the things Priyanka, what are the values you need for the small cone? No. In order to answer any question, what are the values you need to know about the small cone? Radius? Yeah, radius and for a cone, fine. Here, tell me the formula. What are the formulae we have for a cone? What's the formula to find the volume of a cone? What's the formula to find the volume of a cone?
Ma'am, 1 pi r square h, ma'am.
Very good, Nandini. Shreya, CSA of a cone. CSA, the formula to find the CSA of a cone. Oh, you have not learned volumes and surface areas in schools yet? Last year we've learned, but this year they started? Okay, no, fine. Tell me. Still to learn, is it? Formula, fine. Next class, come prepared. They pick pi RL, CSA pi RL, TSA pi R into R plus L. See, formula should be like ABCD. We don't forget numbers and letters, right? And your Tamil, you don't forget your Tamil letters. So like that. Should not forget all this. You should make it a point to remember. It is easy to forget. It's human to forget. But you must make sure you don't forget it. For that, whatever practice is needed, you should do that. Ask yourself, is it nice to forget a formula? It's definitely not. Formula memorize பண்ணாத அளவுக்கு நம்ம irresponsible-ஆ இருக்கும். அந்த பொறுப்பே இல்ல நமக்கு 10th standard வந்து. அப்படி நினைக்கணும் நீங்க, நான் சொல்லல. நானா இருந்தா அப்படிதான் நான் நினைப்பேன். It's all a responsibility. ஃபார்முலா கூட ஞாபகம் வச்சுக்கணும்ன்ற பொறுப்பு இல்ல நமக்கு. எவ்வளவு பொறுப்பு, நமக்கு எவ்வளவு பெரிய பொறுப்பு இருக்கு. இவ்வளவு போர்ஷன்ஸையும் படிச்சு ஞாபகம் வச்சுட்டு எக்ஸாம்ல கொஸ்டினை பார்த்த உடனே ஒர்க் பண்ணும். அப்பதான் 3 மணி நேரத்துல பேப்பர் முடிக்க முடியும். நம்ம ஃபார்முலா யோசிச்சுட்டு தலையை சொல்லிட்டு இருந்தா அவ்வளவுதான், பேப்பர் முடிக்க முடியாது. So this is definitely irresponsibility. Formula should always be when you're writing at your fingertips, when you have to say orally at your tongue tip. Orala keta formula tongue tip la iruknom, எழுதான finger tips la இருக்கணும். மறந்து போகக்கூடாது formula. What's your name? Like that it should be. CSE of the cone na Harini சொல்ற மாதிரி டக்குன்னு சொல்லணும். பறந்துட்டேன்னு சொல்லுவோமா? You know it. Okay, tell me, what's the total surface area? What's the formula to find the TSE of a cylinder? 2 pi r into r plus h. Okay. Length of the diagonal of a cuboid. What's the formula to find the length of the diagonal of a cuboid? Very good. Root of L louder. Root of L square plus B square plus H square. I don't know what you said. Root of L square plus B square plus H square. Yes or no, Nanda Harini? Do you fight with your brother? Do you fight with your brother? Will you do this like this? You'll talk to him? No. You'll roar like a lioness. அந்த மாதிரி சொல்லுங்க. Root of L square plus B square plus H square. Cone, sorry, cube, diagonal of a cube. Rajeshwari, what's the formula to find the length of the diagonal of a cube? I don't know, Rajeshwari, in today's class, you're not so active. I don't know what you're doing. Is your mic fine? Please tell me on chat at least. Oh, Sashmin, you also multiplied numbers, is it? Okay, I'm just reading your chat. Okay. All right, so as you know, we were talking about the small cone, what values we need? We need the radius and height. And for the big cone also, we need radius and height. Because the formulae for a cone are all based on the values of R and H. And once you know R and H, you can find L. Why, Shreyas, you're not normal today. You're tired. You're thinking about the answer. So you need the values of R and H. Once you have R and H, you can find L. L is equal to root of H square plus R square. Correct? You can find L. Now, what I'm trying to say is, now for the double cone, when you find, the question is based on the double cone. What is the volume of the double cone? TSE of the double cone. Listen to this, remember this. It is enough if you find the radius of both the cones. You don't have to find the height. You will see why. For a double cone, there are two cones. One cone has radius height. The other cone also has radius and height. What should you find? It is enough if you find R1 and R2. It is enough if you find R1, R1, R2. Radius also is the same for both the cones. Why is the radius the same for both the cones? Because the cones are stuck. They have the same circular faces. Yeah, same base. So radius is also one only. There's no R1, R2 like I said. There's only one thing which is R. And now this H1, H2. One is a small cone, the other one is a big cone. There's H1, H2. That you don't have to find. We'll see why. So we have to find R. There is no R1, R2 because the value of R is the same for both the cones. One R we should find. Then height, you don't have to find. H1, H2, don't find. Slant height, it's already there. Slant height of one cone is 10. Slant height of the other cone is 24. That's there. So you just have to find the radius. Remember that. When you have to answer questions based on a double cone, find only the radius. Find only the radius. Find only the radius. Need not find the heights. Slant height is already there. Is that understood? Now, how to find the radius? You can find the radius using the concept of similar triangles. You can find the radius using the concept of similar triangles, or suppose this question was in 9th standard. You don't know similar triangles. Then how will you do? So we'll do the 9th standard version first and then the 10th standard version. So this is 9th standard version. If I'm teaching a class of 9th standard students, this is how I would do it. So same, this question can be in 9th standard also. Now they do not know similar triangles. So this is how we do it in 9th standard. Now for you, you can do this one. You can do any method. You can do this one. This is based on similar triangles. So let's see the 9th standard method now. All right. Again, focus. Area of triangle ABC. See the figure. Area of triangle ABC is equal to half base into height. Half into base AB. Half into base AB. See here. Base into height is the sides containing the right angle. See, this is the base. This is the height. The sides containing the right angle. Base and height. The sides containing the right angles. So half into AB into AC. Half into AB into AC. Area of triangle ABC, which is half into 10 into 24. And on cancelling, you get 120 centimeters square. Now the area of the same triangle can be found using the formula half base into height, taking BC as the base and AO as the height. Area of the same triangle. Area of the same triangle can be found by taking BC as the base and AO as the height. Will that also not be 120? That also will be 120 only. It can't be different. You're finding the area of the same triangle. So half into base BC into height AO is also 120. Will also be 120. So half into base is 26. BC is 26. 26 into height AO is equal to 120. When you work this, you find AO is equal to 120 by 13. And what is AO? That's the common radius of the two cones. We found the radius, finished. So how do we find it? Area of triangle ABC, that's all. Finding the area of triangle ABC in two different ways. Taking AB as the base. Okay, Deepika, tell me first taking which as the base? Next using BC as the base and AO as the height. So using this, you're able to find the value of AO, which is the common radius for both the cones. We got the radius, that's all. Now how will we find the volume? See, we did not find height at all. We don't want it. Why we don't want it? See ahead. Volume of the double cone is equal to volume of the small cone plus the volume of the big cone. Yes, right? Yeah. So it is 1 by 3 pi r square. Now I have not used r and h. I've written the line segment straight away. You can also write it like this. R is what? OA, right? So 1 by 3 pi OA square into h. What is h? OB. Yes or no, children? The cone is like this. The circular face of the cone is here. The cone is like this. So the height is here like this. So this is the height. BO is the height. Plus 1 by 3 pi. Again r square. Same thing. OA square. Same thing. This is the radius. Into height. Height is OC. Height of the other cone is OC. Now what is common? 1 by 3 pi OA square is common. This is one expression. This is the other expression. What is common between the two expressions? 1 by 3 pi OA square is common. So I've taken out that 1 by 3 pi OA square. I've taken out common. So what do you have in the bracket? OB plus OC. In the bracket, you will have, see here. Now you have like this 1 by 3 pi r square h1. 1 minute, 1 minute. Look at this. You have 1 by 3 pi r square h1 plus 1 by 3 pi r square h2. What's common? 1 by 3 pi r square is common. In the bracket, h1 plus h2. That's what I've done here. That's what I've done here. So you will get OB plus OC. And what is OB plus OC, children? What is OB plus OC? Hypotenuse. See there, OB plus OC is BC and BC is 26. So you don't need the heights at all. So 1 by 3. 1 by 3 pi is 3.14 into OA square. 120 by 13, 120 by 13 into 26. Work that and find the volume. We are done with the volume. Next, total surface area. Total surface area of the double cone is the CSA of the small cone plus a CSA of the big cone. CSA of the small cone plus a CSA of the big cone. Because the circles are not visible. See here, you can only see the curved surface area here and here. You can't see the circles. So the TSA is, CSA of the small cone is pi RL. See here, pi R OA, L is AB. Plus pi R, again, what is R? OA into L, AC. Pi RL is the formula, CSA, pi RL. So what's common again? What is common? Pi into OA is common. So in the bracket, you have AB plus AC. So pi is 3.14, OA is this one, AB plus AC, 10 plus 24, 10 plus 24. That's all. It's very simple. See, a volume of double cone, you know that it is this. And TSA of the double cone, you know it is this one. And to work this, you only need the value of R. And to find the value of R, 9th standard. Area of triangle is equal to half base into it. That idea. So when you're revising the sum also, you should revise like this. You should not go through the answer. You must recall the procedure. You must remember that it is enough to find the radius. That's the first thing. You must remember that it's enough to find the radius. How to find the radius? By using the formula, area of triangle is equal to half base into height. Should find the area of the same triangle in two different ways. That's all. Finished. You have revised this. You can't work this. There's no point working this. You should recall the idea. Understood? Now using the concept, this is for 10th standard, using the concept of similar triangles. So take up. So I have taken up which triangles. You can again do it in different ways. I'll just see what I've taken. OBA. Okay, fine. I've taken this small triangle. I've taken this small triangle and the whole triangle ABC. See here, I've taken this small triangle. I've taken this small triangle. The small triangle A, B, O, and the whole triangle ABC. And the whole triangle O. I've taken the small triangle. Let me draw it again. ABO and the whole triangle ABC. Now in the small triangle, this is 90 degrees. In the big triangle, this is 90 degrees. And in the small triangle, we have B. In the big triangle also, we have the same angle B. Children, when you come back from school, if possible, take a shower or at least wash your face. Don't come and sleep in my class. So what I'm saying is to whomsoever it really relates to. So you know who's dozing. If you're sleeping, it is for you. If you're sleeping, it's for you. If I'm sleeping, it's for me. No one is sleeping in the class. Because I'm giving all my energy to explain. And you're using all your energy to sleep. Yeah, so we take up, you can take up, you just take one small triangle ABO and the whole triangle ABC. You can also take the other triangle. Which is the other triangle? Which is the other triangle, Ram? Louder? Okay, there is dash இல்ல அந்த பக்கம் கீழே இல்ல மேல தான் சொல்றேன். Yeah, AOC and ABC. Very good. So you can also take up that other triangle AOC and the whole triangle ABC. Take the whole triangle. Take the whole triangle with the triangle on this side ABO or the triangle on the other side AOC. Any one triangle. It's easy to prove that they are similar. It's easy to prove that they are similar because both the triangles are right triangles and one common angle. One common angle. This is the common angle. So the two triangles are similar by doubly similarity criterion. And in similar triangles, so how do you see here? How do you name the triangles? If you say right angle O, then the common angle B, then the third vertex A, then it will be right angle A, common vertex B, and the third vertex C. OBA, ABC. That's what I've written here. OBA. That order is very important. OBA, ABC. You cannot write it however you want, or I can't write it however I want. The order is very important. O is the right angle. A is the right angle. So O means A. B is the common angle. B. So B, B. Then the third vertex. In the small triangle, the third vertex is A. In the big triangle, the third vertex is C. So this is the order. This one only is the order. What is the order? This is the order. Right triangle. This is similar to this one by AA similarity criterion. So in similar triangles, corresponding sides are proportional. So you have OB, you can understand this. In similar triangles, corresponding sides are proportional. Understand that? And then fill the value. Before that, you should have found the hypotenuse. Then fill the values you know. Okay, fill this. And then now what do we want to find? We want to find only OA. So you can equate only this. You can equate only this. You don't have to find the others. See, OB you don't have to find. I have found OB. That's just for you, me to explain. You don't have to find OB. You just find OA. So equate this one. Equate this and find OA. Equate this and find OA. That's enough. We only want the radius. We don't want anything else. Equate that. So you don't have to work this. You don't have to work this. You just have to work this one because we want only OA. And find OA. And then the same procedure, what you saw on the earlier slide. Same thing. So the idea is using area of the triangle or similar triangles. That's all it is. Again, understand this one. Now, how I want you to write, I'll tell you that, okay? I'll tell you how I want you to write. First, write the question, draw the figure and all that. Write this one first. Then write or, and write this one. Write this one. Because this working is common to both. This working is common to both. Understood what I said? Yeah. Start writing. Sashmi, Nandini and Rajeshwari, please work.
Yes, ma'am.
Yeah.
Ma'am, and we didn't work any of the other questions, ma'am.
You did not work, huh?
Yes, ma'am. That 4, 5, and 6 sums.
Oh, okay. That 4, 5, 6 we have not worked. Is it? Fine, fine. Thank you. Yeah, we'll do it now then. Thank you. Children, I'll just take you to the next slide. Online children can take a screenshot. Just make a note of this, fast. Then because then I'll put you on this slide. So you can write everything. Just make a note of this one very fast. Done, children? You want some more time to go through the answer? No. What time do you all come back home from school? 4:50. 5 you're home. All of you home by 5 or before 5? Okay, so our further classes will be on the same days from 6:15 to 9. Same days. Thursday and Saturday from 6:15 to 9. So the first, maybe 1 hour, I don't know, or maybe the first, maybe till 7:30, you will write a test. And after that will be the teaching session. And test will be like, I have prepared the answers also. So when you're writing, I'll just come around you. It's not that, writing test, collecting papers, correcting and giving it after 20 days when you forget what you have written. And then you take the paper and fold it and put it in your bag. There's no point at all. You don't. So test is like questions are on the board. You work it. I'm coming around. You can even ask me if you don't know something. I'll help you there itself. So let's see, what's the point in writing a test? You need to know the answers. Correct? You need to understand. So I'll come around. If you want help, I'll even help you. So like that, it's kind of a practice come test, however you take it. Or you strictly want to try it yourself, fine. And we'll discuss the answers at the end of the class. So you'll be self-evaluating. It's not that writing test. I can make a paper for 3 hours, give the paper and chat with my family. And so go sit there and, waste your time. I don't know, somehow I don't believe in something like that. You're already writing the test in school. So here you come to learn something. And there's hardly any time to practice at home because everybody's squeezing you. School is giving you tests. From all sides, you have, punches and pressure. So I don't want to tax you with, portions. Now come prepared with 5 chapters, test tomorrow. No, there will be a test. I will announce the chapters, but you don't come. Meaning, I'm not saying don't come prepared. There's no time to come prepared. You just come with whatever you know. You've been studying for the tests and exams at school, right? Yeah, that's enough. You just come like that. If there's time, you practice. I'm not saying you don't study, please. Don't take it as a burden. Please study. You have time, please go through. So like that, every class in future will be the first part of the class will be a test, wherein the questions will be on the board. You will work. I'll come around. Any doubts, I'll help you there itself. Otherwise, the answer will at the end of the test, the answers will be on the board, and we'll discuss the answers quickly. So you will get to know your mistakes, and if at all you have something else to ask, you can ask me. And it ends there. So you can evaluate out of put up the marks for. Mostly it will be 1 mark per question. So either it is 0 or 1. Either you don't get marks or you get 1 mark for that. You evaluate it yourself, and if you want, you can tell me your marks. You don't want to, don't say. It's like that. All right. So Thursday, Saturday from 6:15 to 9. And Sunday, I'll let you know. Sunday will be in the morning only. I'll let you know the time for Sunday. All right. So Sunday's class will be for 2 hours only. Not more than that. I've not planned for more than that. Let's see, I'll let you know. All right, the regular sessions will be from 6:15 to 9. What phase? That'll be difficult for you. Then you'll skip the test and come only for the regular class. I'll share the questions with you. You can work it as homework. Yeah. See, if parents feel like, why she's also like, extended the time. How can my children, or how can my child sit for such a long time in the class? If your parents have concerns, no force. You can come for the regular class at 7 o'clock. I'll be here, and there'll be at least one student for the test. I think at least one student will come. So that student will write the test. That's all. The others can take the paper and do it as homework. That's your choice. If it's going to be difficult, that's your choice. There's no compulsion. So then it'll be a regular classroom 7 to 9. All right. No, all of you are coming. Shreyas is finding it difficult. Anybody who's finding it difficult must let me know. It's not, I'm not giving you an option like that, but since he said you're all coming, the day you're not coming, you have to text me. You cannot decide that by yourself. Online students, got it?
Yes, ma'am.
All right. Any questions here? Yeah, this is also 9th standard. Do this. It is now in your NCERT textbook, but it's 9th standard. NCERT, yeah. And my thing is that protective wall is made around the mouth of the pipe. So the various was the thing at the glass, right? So then, it's dangerous. Why is there a wall to break around the mouth of the pipe? Protection. I've seen it. So arm is strong. Because of the arm. And then see with the wellness cylinder, and the wall around the bed is not a full wall. The wall is built around the mouth of the bed. The cylindrical bed is circular mouth. And how the environment is built around the mouth of the bed twice. And then you have to put the wires. So I'm not sure. Okay. Yeah, online students, if you do not have the correct idea, please listen to me now. Yeah, children. A well whose diameter and the depth is given. So it's a cylindrical well, right? It's a cylindrical well. So you know the for the well, you know the radius and the depth. For the well, you know the radius and the depth. So you can find anything for the well because you know radius and height. And the earth dug out. So when you dig, when the well is dug, earth is removed, right? The earth which is removed is used to build that protective wall around the well, around the mouth of the well. The earth which is removed is used to build the protective wall around the mouth of the well. Because when you dig the well, it is on the surface of the ground. So there is a wall built around the well, right? Around the mouth of the well. What is the shape of the mouth of the well? Circular. So the wall which is built around it is a cylindrical shell. It's not a solid cylinder. It's a cylindrical shell. That means the wall is thick, right? It's cylindrical and the wall is thick. So it looks like that sellotape. Something like this. Something like this is how the wall will be. The wall around the mouth of the well will be something like this, see like this. Correct? This is the wall. This is, see, this is the well. This is the wall. This is the wall. Now you can draw, you lean on this wall, no? When you stand, you lean on this wall. When you want to draw water from the well. When you want to draw, have you ever drawn water from the well? Yeah. No? Yes. Have you drawn water from the well? Never. Not once. Okay, have you at least seen people drawing water from the well? Yeah, at least movies or somewhere we've seen, right? Yeah, so normally the person leans against the wall. So that wall this is. That wall. So how is the wall? If it's fully closed, then how will you draw water? So it'll be like this. So what is this? This cylindrical shell. This one is a cylindrical shell. See, the wall looks something like this. It's a cylindrical shell. The wall around the mouth of the well. The mouth of the well is circular and the wall is built something like this, which is a cylindrical shell. Cylindrical shell. And how do you find the volume of a cylindrical shell? See, volume is always, see, these are things which you need to give importance to. And some of us are busy writing. So how do you normally find volume for a solid which has a uniform cross section? Can anybody tell me? Somebody's come out. Is it for any of you here? Ask the person to come in and sit down. No? உள்ள வந்து உட்கார சொல்லுங்க. Ma'am, please come in, ma'am. Please sit down. Okay, ma'am. Please sit down. Yeah. So, yeah. Now, I was telling you, how do you find the volume of a solid which has a uniform cross section. Now let's recall that. Now a cuboid has a uniform cross section which is a rectangle. A cuboid has a uniform cross section which is a rectangle. Okay, and what's the area of a rectangle? L into B. Now, how do you define the volume of a solid that has a uniform cross section? So volume of cuboid. Volume of cuboid. The cross section of a cuboid is a rectangle. And volume is always area into height. Volume is area into height. And what's the area of the cross section? L into B. Rectangle, L into B, into H. So volume of a cuboid is LBH. What's the volume of a cube? This is only for, solids that have a uniform cross section. For solids that have a uniform cross section, the cross section of a cube is a square. The cross section of a cube is a square. What's the area of the square? A square. A square into height of the cube, A. So A cube, cubic units. What's the volume of a cylinder? It has a uniform cross section. What's the uniform cross section of a cylinder? Circle. Circle. You stack identical circles. When you stack identical circles to any height, you stack identical circles to any height. That's a cylinder. A circle is a plane figure. A circle is a plane figure. It has no height. A circle is a plane figure. You can draw it on the board. It has no height. When you have identical circles and you stack it to a particular height, the solid is a cylinder. So the cross section of a right circular cylinder is a circle. And how do you find the volume of a cylinder? Area into height. What's the area of a circle? Pi r square. Area of the cross section, which is a circle, is pi r square into h, pi r square h. Now a cone does not have a uniform cross section, so you cannot derive it like that. A cone does not have a uniform cross section. A sphere also does not have a uniform cross section. There is a cross section, but it's not uniform. It will keep increasing or decreasing in size for a cone. Yes or no? So for that, you cannot do this one. This is for solids that have a uniform cross section. It's area into height. Basically, volume is area into height. Now, this cylindrical shell, what is the cross section? What is the cross section of this cylindrical shell? Huh? It's a ring. Circular ring. Minus the area of the small circle. Pi capna square minus small r square. We have seen this in, I think right from standard 7. How do you find the area of this region? How do you find the area of this region? It is the area of the bigger circle minus the area of the smaller circle. Minus the area of the smaller circle. That means pi common, capital R square minus small r square. Right? So the cross section of a cylindrical shell or, a wall like this. This is the cross section. If you have many identical pieces like this, if you have many identical rings like this, you stack it, you will get this cylindrical shell. You will get a solid like this. This is a solid because it has height. It's a solid. It has height. Yes or no? The cross section is a ring. What you see on the board is a ring like this. I've shaded this one. And how do you find this area? Pi capital R square minus small r square. So the area of a the volume of a cylindrical shell or a wall which looks like this is area of the uniform cross section into height. Volume of this one is area of the uniform cross section. So the volume of the wall or the volume of the embankment which is built around the circular well. All right. The volume of the embankment or the volume of the wall which is built around the circular well is area of the uniform cross section into height, which is pi r square minus r square into h. This is the volume of the embankment is equal to the volume of the well, which is pi r square h. That's a cylinder. The well is a cylinder. And the earth which is removed from the well is used to build the embankment. So the volume of the earth which is removed from the well is equal to the volume of the earth in the embankment. That is the equation in words. That is the equation in words. The volume of the earth removed from the well is equal to the or is the same as the volume of the earth, which is used to construct the embankment. These two volumes are the same. So that is the equation. That equation is what you should write first. You should not work separately. See here. Don't write anything. Volume of the embankment is equal to embankment, meaning the volume of the earth there, is equal to the volume of the well. And how do you find the volume of the embankment? Pi capital R square minus small r square into h is equal to the volume of the well, which is pi r square h. Now the radius of the well and the inner radius of the embankment is the same. See here, the inner radius of the embankment and the mouth of the well will be there only, no? The mouth of the well. This is the mouth of the well. Around that only, when you look inside the well, you know, the mouth of the well and the inner circle of this one will coincide. That's how it's built. You can see the well and on it you can see the wall. The well and the wall which comes from the mouth of the cylinder. So the mouth of the well is here inside here and this wall will come outside like this. So the radius of the well is the same as the inner radius of the embankment. The radius of the well, you should imagine that the radius of the well is equal to the inner radius of the embankment. That's all. Just substitute the values. So now let's do it here. See, pi gets cancelled. That's very important. That's why we have to work it like this, not separately, because pi gets cancelled on both the sides. And for the well, what's the diameter? 7. So 7 by 2 is the radius. So 7 by 2 into 7 by 2. What's the height? 22.5. All right, on this side, the value of capital R, we don't know actually. 1 minute. What is the small r for the embankment? 7 by 2. 7 by 2. The radius for the embankment is 7 by 2. And what's the width of the embankment? We don't know. So capital R we don't know. Minus small r, 7 by 2 the whole square. Into the height of the embankment. What is the height of the embankment? 1.5. This is the equation. You must write the equation in words and substitute the values. This is the easiest way of getting the answer and not by working it separately. Do it. First, go through the presentation, understand the values, and then write them. You can just make that corrections. It's R only in both the cases, and you can just remove that. Whatever I've corrected, please do the same corrections. Finished, huh? Hitesh? Are you writing the questions or no? That's what, see. It's time, children. I've shared the picture on WhatsApp. If you have more lots to complete, your parents are waiting. So shall we wind up? I've sent the picture in the group. Maybe you can complete it at home. It's time. It's 10 minutes past 9. All right, children. So online students, that's it for today's session. If you have not completed, please take a screenshot. If you have not completed, please take a screenshot. I've also shared the picture in the group. You can see it on WhatsApp. All right, Sashmin, Priyanka, not Priyanka, that Rajeshwari and Nandini. That's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you.
Yes, Nandini. Yeah, thank you. Good night. Thank you, Rajeshwari. Thank you, Sashmin.